Let's talk about one of the biggest paradoxes in all of education. It's this massive gap between the incredible promise of chemistry and the often, well, frustrating reality of actually trying to learn it.
I mean, think about it. On one hand, we're told chemistry holds the keys to solving our biggest global problems. But on the other hand, for a lot of us, it was just that class, the one with the impossible formulas and that periodic table we had to memorize. So which one is it? Let's unpack that.
So, first things first, let's just establish the stakes here. Why is chemistry so incredibly important? Because it's not just about lab coats and beakers. Not at all. It's really about building a better world. When you look at the huge global issues, we're talking climate change, pollution, sustainable development, chemistry is right at the heart of the solution. It's the engine that drives everything from renewable energy to cleaner water. It is absolutely vital for progress. And this isn't some far-off theory. This is happening right now. We have new plastics that can literally dissolve in the ocean. We have enzymes that can recycle plastics perfectly without them losing quality. We're even using microbes to replace harmful fertilizers. These are real-world, game-changing breakthroughs, all powered by chemistry. But it's about more than just the discoveries. Learning chemistry fundamentally changes how you think. It's about building this mental toolkit that helps you analyze information, see patterns, and solve complex problems. And you can apply those skills to pretty much anything in life. Okay, so if chemistry is so amazing and so important, why do so many of us find it so incredibly difficult? Well, the truth is, it's not just in your head. The challenge is actually baked right into the subject itself. And here's the first huge hurdle. In biology, you can look at a cell through a microscope. In physics, you can watch a ball drop. But chemistry? It's all happening in a world that is completely invisible. You have to build a detailed picture in your mind of atoms, electrons, and bonds, things you will never, ever be able to see. And it gets even trickier. Chemistry forces your brain to be a kind of mental gymnast. One minute, you're memorizing rules and properties, almost like you're learning a new language. The next, you have to completely switch gears and use pure logic and math to solve an equation. You're constantly jumping between these two very different ways of thinking. This stacking blocks analogy is just perfect. You can't just cram for Chapter 2 and then forget it to make room for Chapter 3. No, everything builds on what came before it. If you don't really get that first block, say how to write a chemical formula, the whole tower is going to collapse when you get to balancing equations. It's cumulative and it's totally unforgiving. And that wobbly tower, it has very real consequences. Research shows that a staggering 42% of students who fall behind in chemistry do so because they missed a single early concept and just couldn't catch up. The foundation wasn't solid, and the whole thing came crashing down. So, okay, the subject itself is hard. We've established that. But what if the way we teach it is actually making things even worse? Let's dive into this disconnect between the cutting-edge field of chemistry and the often static reality of the classroom. There is a formal name for it, transmissive pedagogy. But really, it just means the traditional lecture. The professor stands at the front and talks, and the students are just supposed to soak it all in. It's a one-way fire hose of information, and research shows this model, which really promotes memorization, is still the main way chemistry is taught at a lot of universities. And just listen to this quote from a university lecturer. He admits it himself. His lectures haven't changed in years. Same materials, same order, even the same jokes. It's just wild when you think about it. The field of chemistry is making revolutionary discoveries, but the way it's taught can be stuck in a time warp. And what do the students say? Well, they show up expecting that lecture format, but they often find it boring or monotone. And the result? The real learning doesn't even happen in the classroom. It happens later, when they're alone with the textbook, trying to piece it all together. The lecture itself often fails at its one job, to actually teach. All right, now we're getting to the absolute heart of the problem. This massive, massive gap between the skills universities say they want to teach and what they actually ask on the final exam. Just look at this. The course goals sound fantastic, right? They want to develop critical analysis and problem-solving skills. But then look at the exam questions. The verbs are all about simple recall. Define, describe, state, list. We're telling students we want them to be innovators, but we're grading them on how well they can memorize facts. The test just doesn't match the mission. So here's the bottom line. Education is supposed to get students to the top of this ladder, to analyze, evaluate, and create new things. But the exams that decide their grades are often stuck way down on the bottom rungs. They're rewarding memorization and basic skills, not the deep critical thinking that we claim to value so much. So the problem is pretty clear. The question is, what do we do about it? How do we finally close this gap between the amazing promise of chemistry and the reality of how we practice it in our schools? And here's the key takeaway. The goal isn't just to make chemistry easier. The real goal is to get our teaching methods and our tests aligned with what we actually want to achieve, creating a generation of real critical thinkers. It's all about alignment. And really, that leaves us with this one big, nagging question. If our education system is primarily built to reward memorization, how can we ever expect to produce the innovators we so desperately need? Are we building the chemists who will save the planet, or are we just creating students who are really good at passing a test?